So to apply the method of undetermined coefficients to a problem like this, the first thing that I would do is notice that we've got two forcing functions here. We've got an F1 and we've got an F2. And it will be a lot easier to solve this if we split the problem up. So we'll be looking at y double prime minus 3y prime minus 4y equals 3e to the 2t, and we'll solve that one to find y1. And then we will look at y double prime minus 3y prime minus 4y equals 2 sine t, and we'll use that to find y2. So in other words, I've split this up into the problems, the two problems. Ly1 equals f1 and Ly2 equals f2. And so then if I take my particular solution to be y1 plus y2, linearity, actually I don't know why I'm writing those square brackets. Let me just write it like this without the square brackets. When I apply L to yp, then by linearity I will get Ly1 plus Ly2, which is f1 plus f2, which is what I have on the right hand side of my equation right here, f1 plus f2. So we break it up into the two parts. So for the first part, my guess is going to be, let's see, so f1 is an exponential function, so I'll take y1 to be an exponential function, and I'll use a capital A for the coefficient that has yet to be determined. Okay, so then if I plug y1 into the equation, what do we have? Well, the first thing is its second derivative, so that would be 4ae to the 2t. And then the next thing is going to be minus 3 times, and here I need to put its first derivative, so that's going to be 2a e to the 2t. And then I've got minus 4 times the original guy, a e to the 2t. And so this is, there's my y double prime term, and there's my y prime term, and there's my y. Okay, so I have substituted it into my equation now, and collecting up these terms, what do I find? I find, let's see, so there's 4a minus 6a minus 4a e to the 2t, and that's supposed to be equal to, and my f1 was 3e to the 2t, so that's f1. So my equation for a then is that I've got, I guess, minus 6a on the left side, and I've got 3 on the other. So a is going to be equal to minus 1/2, and my particular solution for this part of the problem is going to be minus 1/2 e to the 2t. All right. Now I can go ahead and solve the other part. So for the other part, oops, let me line that up a little bit better. I'm going to guess that y2 looks something like a sine t. All right. So then if I substitute this in, L of y2 is, and so I've got the second derivative of this guy, so minus a sine t, and then I have let's see, minus 3 times the first derivative, and then I have minus 4 times the original thing. And so gathering this all up, I have, let's see, so minus 5a sine t minus 3a cosine t. And so this then is supposed to be equal to f2, and f2 was 2 sine t. So now if I gather up the equations on both sides for the sine t term, what do I have? I've got, oh, I just realized back here I called it the A equation. That was wrong, silly and misleading. That should have been the e to the 2t coefficients. That's what we were collecting. Just like over here we're collecting the sine t coefficients. And on the left we have 2, and on the right we have minus 5a. And then for cosine, on the left side there's no cosines, and on the right side we have minus 3a cosines. And so the second equation says that a is equal to 0, and the first equation says that a is equal to minus 2/5. And it's a long-known, well-standing fact that 2/5 is not equal to 0, or negative 2/5. So something is wrong. Right, what happened? Well, probably you already spotted what happened. My guess back here was lousy because I didn't take into account f prime or f double prime, right? So what I said on the previous clip was that we should take those into account. So I had a poor guess, so I have a revised guess now. Let's take y2 to be a sine t plus b cosine t, and see if we do any better. So then let's see. So if we look at the second derivative of this, we're going to have minus a sine t minus b cosine t, and then we'll have minus 3 times the first derivative, so that'll be minus a cosine t. Oops, what am I doing? That one's positive. And that one's not. Minus b sine t, and then we have minus 4 times y2 and that's all supposed to be equal to f2. So collecting this up, let's see how many sines do we have. We have minus 5a plus 3b sines on the left, and on the right side from the forcing function we have 2 sine t. So this is our sine t equation, and for our cosine t equation, and I guess it doesn't matter whether or not you write them, so I didn't actually need to write those, but who knows, maybe it makes it more clear if I did. So for the cosines we have minus 3a cosines, and how many b cosines do we have? We have minus 5. Yes. And there's 0 on the right hand side. Okay, so then that gives us a linear system minus 5, 3, minus 3, minus 5 to 0. And we can row reduce that sucker, and we get a solution this time of minus 5 over 17 and 3 over 17. So our y2 is going to look like, well, here, you know what? We'll just string the whole thing together now. So we've got our y1 part, which we already found was minus 1/2 e to the minus 2t, positive 2t. And then we've got minus 5/17 sine t plus 3/17 cosine t. And there's our full particular solution.